Another very important rule is the chain rule as to the derivative of a function f that is a function of another function u of x is equal to df by du times du by dx. Let's see it in an example. If we have u as a function of x equal to x squared plus 1 and f of u as a function of u, it's equal to u squared. Then the derivative df by dx is equal to df by du, and looking here, this is the function, so its derivative is 2u plus times the derivative of u with respect to x. Here is the function. Then the derivative is 2x. Then we want the derivative of f as a function of x, so we need to substitute every u that we have with x. So u is equal to x squared plus 1. So the final formula is going to be, or the final version of the derivative is going to be 2 times x squared plus 1 times 2x. Another important rule is the quotient rule. That is d. Let me change. That is d of the derivative of function f divided by function g is equal to the function g, the denominator, squared, and in the numerator we have g, function g multiplied by the derivative of the function f minus f multiplied by the derivative of the function g. This rule could be derived from first principles, but as we did derive the product rule from first principles, I want to start from the product rule. So let's write down the product rule, how it looks like, and then we're gonna plug the functions in it and work on the derivative until we arrive to the quotient rule. So the product rule is if we have two functions u and v, the derivative is equal to u dash, the derivative of the first function u multiplied by the other function v, plus u times the derivative of the second function v. Then substituting with the functions that we have, then it's equal to f of x times v. Now what is v? V is 1 over g. Let me highlight it here. U is equal to f of x and v is equal to g 1 over g of x. We're treating the two functions as if they are multiplied by each other. So it's f of x multiplied by 1 over g of x. So the v is g of x all to the power negative 1 plus u is, here it's f dash, the derivative of here, the derivative of f times v, which is g of x to the power negative 1. And here u is f of x times the derivative of the second function, which is g of x to the power negative 1 derivative dash. Then the first term here, it's already evaluated. We don't need to simplify it further. But let me write it as f dash of x, and I'm gonna put the g of x in the denominator. Now plus this second term, but I want to evaluate the derivative first. Let me delete that here. I want to evaluate the derivative of g of x all to the power -1, the derivative. So for that, we can use the chain rule, and we have the outer function as the function raised to the power -1, and the inner function is the g of x. So it's going to be -1 times g of x to the power -2 times g dash of x. So now substituting this derivative that we got here, it's going to be, the second term is going to be f of x times minus g of x to the power -2 times g dash of x. So let's write it here in a cleaner way. So we have here f of x dash divided by g of x minus g of x to the power 2. And here, as we derived, we have f of x times g dash of x. Then unifying the denominator, we could put it as g of x all to the power 2. And as we change the denominator here by multiplying by g of x to have it as g of x to the power 2, we need to multiply the numerator also so that we don't actually change the term. So it's going to be f of x, f dash of x, the derivative of the function f, times g of x minus, here the numerator of the second term stays as it is because we didn't change the denominator of it. So it's f of x times g dash of x. And this is the final version that is representing the rule for quotient, or the quotient rule.